All right, we should be live. Microphone seems to be working, camera's there, and we're recording. Great. So, this is the third stream in a series of streams we've been doing on a Rust crate that I've been working on called Juniper from Schema. So, I don't know if I want to keep doing this intro every time, but just for the new ones here today, we'll do it one last time. You can always find my past streams on YouTube, by the way. So Juniper is a client library that allows you to write like servers, GraphQL servers in Rust. But one sort of key feature that they're basically missing is the idea of having an actual GraphQL schema file that is sort of the canonical truth about your schema that you can then share with clients or whatever. And then have that sort of derive your Rust code. The way you do it is you use either these derive macros on your structs, or let's see, they have this GraphQL macro that you can call yourself, but like this is still not a GraphQL schema. So what I've been working on is a crate called Juniper from Schema, which is basically a procedural macro for us that takes an actual GraphQL schema file like this. You call the macro like this with the path of the file, and then it generates a bunch of traits and some types for you that you then have to implement, and then all your existing types that you declared in your GraphQL schema just sort of are plugged into to Juniper. So that's sort of how that works. And for the last couple of streams, we've been working on a feature called query trails, which is sort of a wrapper around Juniper's let's see, here is a wrapper around Juniper's lookaheads. So lookaheads are sort of a way to, while you're evaluating some GraphQL query, you can ask Juniper about which fields and which types you're querying for later down the road, so that you can make smart decisions that'll make the rest of the query run faster. You can make those smart decisions up front. And so usually the way that I'll be using this for my work is I use it to basically preload and build database queries that loads more data in one query instead of doing many small queries. And that usually tends out to be faster. And so one particular bug that we've been working on for this is, let's see, is this one, that query trail, it generates like a bunch of methods for each of your types, but it didn't do that in the past for GraphQL interfaces and union types. It only did it for like regular types in GraphQL. And we've been able to get it working for interfaces. So if we look, we released that as a patch version a couple of streams ago. That was this version 0.12. And we've since then been working on getting it to work for unions. And that turned out to be a little bit more complicated than I had first thought. So we have like a first integration test here. And basically, so what we set up is a query where you can get a bunch of posts. Posts have comments. If we look at the comments, they have an author, which is this entity thing, which if we look, that's a union type, which is either a user or a company. So we looked last stream at how Juniper actually sort of generates these lookaheads for us, and how it expects the things to work, or how it makes things work basically. And what it does is you can ask for the combined set of all fields on user and company, and it'll say whether or not they're loaded. So it doesn't sort of decide if try to do anything fancy at runtime to check what's actually been loaded. It just takes the combined set of all the fields, is sort of what the lookahead has access to, if that makes sense. And if you guys have any questions, just put them in the chat and I'll get to them. But the issue that we ran into is that since it takes the combined set of all the attributes, what do you do when two of these types have a field with the same name, but they are different type? So in this case, our user has a country field, that's just a country, and our company has also a country field, but it's of a different type. In this case, it's just another country. This is just a different, whoops, this is just a different dummy type that we just needed for this example. And so what we've settled on doing for now is just detecting that this is happening and then failing to compile, because I'm not sure how else to handle that. Because imagine that you're like, yep, you ask if a country is being loaded, it says yep. What if those those could be different countries, but what if the countries have different fields? They don't in this case, but they might very well in a real world example. So this is yeah, so we've just decided to detect if that happens and then fail. So the code in this crate that's responsible for that we've been working on for the last couple of streams is this module here. This is basically the module that takes a parsed GraphQL document and then it generates Rust code. So previously we were able to build this like map of fields, which is a hash map of some name of a type in GraphQL and then a list of whatever fields it has. So this would be something like company, and then the vector would contain this ID field and this country field. And so what we need that for is we need it to, whenever we like hit a union while iterating over the schema, we need to check if we've seen this, if for any of the fields in that union, we need to check if we've seen that before and if it's of a different type. So how that works is we get the union. Let's just pull up the documentation for that. So I use a crate called GraphQL parser. That's also maintained by the Juniper team, at least it's under the same organization. So if you get a document is either a query document or a schema. A schema has a list of definitions, and we're interested in the type definitions, which can be a whole bunch of things. One of them is a union, and inside there is a union type. So that's the thing we have here. It then has a list of name types. Name types are basically just strings. And so in our case, the name type is going to be user and company. So what we then do is for this union, we look at all the names that we've seen before. So these are the field names and the name of the types. So if we look at a field, a schema field, we can see that a schema field has a name, which is again just a string, and it has a type, which is either a non-null or a list of some other type, or at the very bottom a named type. So these are the only ones we care about. So we basically pull out this name, and so that is what this hash map is. It's the previous fields that we've seen, and then whatever name of type, like what the name of the type that field had, if that makes sense. So then what we do is for each type in the union, in our fields map, we need to figure out what fields does this type actually have. So we look that up in our fields map, and then for each of the fields in that particular field, so this would be like we find the user and then we find each of its fields, those are these ones. We get the name and the name of its type. So like this would be country and this would be int. And then if we've seen it before, whoa, went too far there. And then if we've seen it before, if the type is different, then we panic. If we have not seen it before, then we just insert that into our list of previous fields that we've seen. And so this example here should fail because both user and country have this a country field, but they're of different types. So let's make a more descriptive error here. Same field name, different types. So this works. Our code fails to compile with the error message that we expected, basically. So now the question that we had last time was if it's possible. So since this is a since Juniper from schema is a procedural macro, these tests, as you see, they basically don't have any assertions. They're all unimplemented. So what we're sort of asserting is that the correct code is being compiled, which means that this test basically says that this stuff up here should not compile. And I'm honestly not sure how to test that, other than like having a actually having like a unit test within this file that then hits this panic. I'm wondering now if that's even possible, if we can, because in order to do that we'd have to be able to construct a document ourselves. Can we do that? We probably can, because all the fields are public. Type definition, union, position. We can construct positions, string, directives. That can just be an empty list. And types. I think that is what we're going to have to do, is to basically construct one of these. And then like actually remove this test from our code. Unless, I don't think that we can have like a test, like an integration test like this, that like tests that something does not compile. I know that you can have so you in Rust you can add like to any function you can add this test attribute. If I can use Vim correctly, that will help. And then you can like write assertions. And then if you have an assertion that like should fail or should panic, you can say like should panic, I believe. But I don't think you can say like should not compile. Any plans to support compile fail tests? SRS. An extraction of the compile test utility from the Rust compiler. I think this seems a bit involved. The easiest approach is probably just making a unit test within the file. I think we should approach that. So I just commented out that like big module that we've written before, and now all the tests should pass. Alright, so let's actually try to write such a test. And the test does actually get picked up. I have like a Vim macro. For just doing like the common test setup in Rust. So we need a fails to generate a query trail for unions where fields don't overlap. A document has a vector of definitions. So I have a couple of Vim key bindings for doing like running Rust stuff. Currently, when I hit Command T, it just compiles the code. It basically runs cargo clippy, and which means it doesn't actually compile the tests. So if we like write something silly here, or does it? I'm not sure. Yeah, see, this obviously isn't correct, but it successfully compiles. However, if we do cargo build tests, now it fails. So when I do leader T, we want to fail the build, which means that we can change this to check and also check the tests. That should fail. Which it hopefully does. This is always exciting. Yep. So it has a vector of definitions, which is what we want is a type definition. Oops. Type definition which contains a type definition that is a union. Containing a union type which has a position. Let's see if we can just copy this. Description, none, name. Let's replicate what we had before. So the name of our union is entity. It has no directives and no entity, no types for now. Let's just see that we can actually get it to compile. Does Rust format not format tests? I guess not. Is that because we're inside of a vec macro? No, that should work, right? I guess. I guess there's a syntax error. See what it says. Type definition, ambiguous name. Object not found in the scope. Where? So we've done a couple of like glob imports of enums, which will then import each variant of that enum as a name, which is then annoying when like one of the definitions variants is type definition, which is itself another enum. Then that becomes kind of, the compiler becomes kind of confused. So we just have to like qualify these names here. Alright, so now those errors went away, and it's basically complaining that it needs an actual position, and the name needs to be a string. So here you can just call into, and this needs to be an actual position. Union pos. We probably need to import it. Line 1, column 1, basically we don't care. Great, now we have a document. So the types in our enum are going to be user and company. And those need to be strings again. Whoops. So now we have the union itself. Now we need the user and company type. So those are type definitions, and they are object types. Which is another here. So it's a definition, type definition, object, object type, with Let's give it the same position that I had before. No description, name user, implements no interfaces, has no directives, and fields it has a description, name, country, you know what I'm thinking? It is silly to build this whole thing up ourselves. We can just use GraphQL parser directly and call the part schema function, and then we get a document. So we basically don't need to write all of this stuff. Let's just do that. So the schema so we have a we need some of these things from before, right? And we also need the company, which also has a country, but of type other country. And we need a country. That's it, right? I think so. Because we don't need anything that sort of uses the entity. We just need to hit this branch in our loop, right? So then this should fail to compile, or should panic. Let's first see if it actually compiles. Let's see if the document parsing is successful. It is, that's good news. So now we gotta figure out a way to call this function with the document and whatever this output thing is. Where's that come from? That comes from super. How does this get constructed? Because it has some tokens, which is fine. That can just be an empty list. What this type is basically as we like do a bunch of processing on the document, rather than having to return types, like return bits of Rust code all the time. All functions that need to sort of have an output, they just take this out parameter, which has a method for adding stuff to it. It basically maintains like a list of Rust tokens, and you can then, when you're done with the whole transformation, you can turn that into sort of the final output of your Rust code. and it has a couple of things that we need. Let's just try constructing one and see how it goes. Tokens is empty. And it has these two special scalars and interface implementers. So these are basically things that we need as we're generating the code for our GraphQL. So for example, when we hit an interface, at that point we need to generate a special trait and an enum, and we need to know all the types that implement that interface. So what we do is we make, before we start actually generating code, we do one pass over the AST where we find all the types that implement all the interfaces. So that data is there when we later need it during the code generation phase. And I believe that is just constructed in lib. Find interface implementers. I'm using C tags here to jump to definition. So that is an interface implementers, which is just a thing that wraps a hash map. We're probably going to need some use statements for this. And so this is just one of these. I love that it basically tells me exactly what imports to use. ID scalar used as private. God damn it. I mean, we can technically just call both of these functions with the document, right? Yeah, let's just do that. I think that's actually easier as well. Oops. And we'll again just have Rust tell us exactly which use statement that we need. That works. And it panics. Check it out. Thread panicked at same field name of different types. That works. So if we then say this is a country, for good measure, let's just make the other country type. That passes, and if we set it back to other country, it should now panic. And it does, and then I believe we can say should panic. Yep. And if, just to be totally sure, we fix the panicking, then the test doesn't work because it didn't panic. Great. Let's just clean this up a little bit. Do we need... Don't need this one. I think that's it. No, we don't need the position anymore, right? Because we're just parsing the schema directly. Yep. So now we basically have to get the actual code generation for the union type working in. So this is the code that tests that, I believe. Should not compile. No, this is the code. What does this do? Union type. Critical methods for union types fails if types don't match. I guess that was just the test that we tried to work on last time. Bring this back. So here we basically check at a whole bunch of the methods that we generate, and we check that they're of the right type. So this should fail to compile, because you might have noticed that we had some code that was undocumented, or uncommented rather. Same field name of different type. Interesting. That method should not be hit. Let's see if we can make this method a bit more, like this error message, a bit more helpful. Let's say this is field name, just so we're sure. And this is field type name. Field type name. And then let's just sort of look at the data that we have. Something's wrong. ID other type int. User has an ID of type int, and company has an ID of type string. Huh, that would not work. company. It seems that we left the code in sort of a half-finished state, because in the struct the ID is an I32, whereas here in the field, previously it was a string, it needs to be an I32. So now it should successfully compile. It does not. Yeah, it fails to compile because we're not generating the code. Now we don't hit the panning anymore. That's good. However, we might want to... So I'll add a to-do here to actually give a more helpful error message. What I want to focus on first is actually getting everything to compile, and then we can focus on making it better. We'd also need some way to actually introspect the error message. It would be really neat if we could actually add tests for the error message. Let's think about that when we get there. So what we actually need to generate the methods is we need one of these internal query trail node, which is either an object interface or union. Union is the interesting one. It has that type, the union type. That's this guy here. It has a hash map of name to field. So as far as I remember, that is that's a list of all the types, so of all these, and then a list of all the no, that's the name of all the fields. Right. How does that make sense? Is it all the types in the union, all their fields? So what we do need is we need to be able to return a name. That's just the name of the union. And we need to return a list of fields. So the list of fields should then be, that should then be that combined set of all the fields. So what is this name thing here? It's basically never used. It's just a vec of fields, right? Because all we ever do is take these fields, take the values, clone all of them, put them in a vec, and return them. We're not actually doing anything with the keys. Could go back and watch a past stream, see what the hell we were thinking. So if we take a step back and we think, what do we actually need? So the query trail is for an entity, because that's what we're returning. And then it needs to have, for each type in the union, it needs to have a method for each of its fields. So that means this hash map is just a list of all the fields in the union. So of all the types in the union, all their fields is what we need. So that means, yeah, I think I remember why this is a hash map now and not just a set. Because if we look at field, it does not implement hash for some reason, which means that we cannot put it in a hash set. And as far as I remember, we cannot put it in a B-tree set either, because it has to implement ORed, as far as I believe. Yeah, where the T implement ORed, which field does not. It implements partial EQ and that's it. It could just be a vec. Yeah, I remember now. This is the name of the field, because we don't want duplicate fields. So this is just sort of a way to like make it hashable, basically. Hash it by the name. We could make a wrapper type that is hashable and then just returns the hash of the name. I think that might actually be better, because otherwise we're going to get back to this code a year from now and wonder why the hell this is a hash map. How do you implement hash? You can just derive it, or it seems to be pretty easy to implement. So let's look into actually doing that. So this is a hash set of hashable field. And then we just need to implement hash. Wait, is there anything else that a hash map needs? Does it also need EQ? Yeah, hash and EQ. Let's see if we can also implement EQ. Derive hash for hashable field. Self 0 name. That should work. And now it complains down here that we don't have values. So what we have here is a hash set of hashable field. EQ is not implemented. So we should not be able to derive it. I'm honestly not sure. It seems... No, we cannot derive EQ because it's not implemented for field. Can we implement it ourselves? Yes. However, we should have our EQ implementation match our partial EQ implementation, which basically just compares them on the name. Hashable field 0 name. And then it complains that clone is not implemented. So we can just derive. A collection of type vec GraphQL AST field cannot be built from an iterative hashable field. Right. Oops. So we have to return a vec of field, but we're returning a vec of these hashable fields. Believe that should work, and it seems that it does. Cool, so we get to the tests now. They still don't work, and the reason is that we are not actually calling this method down here. So basically we need to build this hash set of hashable field, and it needs to live as long as the union type. Does that make sense? Let's just say that it is owned for now. So this is a set of all the fields that the types in the union have. And we're guaranteed that if there are fields of the same name, then they also have the same type. Otherwise, we'd panic. So this should work. So we need to somehow build this map here. Union fields set. So we have the field map, which we can probably use. That has all the types and their fields. So we can loop over the types in the union. We need to do something similar, right? Where we loop over all the types in the union, find the field in like all the list of fields, and then its field. Let's just put some debugging in here so we can just see what we're actually working with before we go too far. Fields. So we have the company, and then we have a country of operation field, an ID field, a name, a user, has a country and an ID. If we just check, user has country and ID, company has country of operation, ID and name. So that is working. We basically need to insert these into our hash set. So for each of the fields, a field, is that it? It compiles. Before we get too far, I think I just want to rename this to hash field by name. I think that's a bit more clear what's actually going on. Still compiling. And hey, look at that. The test passed as well. That is fantastic. We actually now have a working implementation of the thing that we've been working on for the last 3 streams. Just to make sure that we're not crazy, let's bring all the previous tests back. They compile as well. And remember that these are like compile time tests, so you don't actually need to run all the assertions. But let's just do that for good measure. And while we're ahead, let's just commit. I believe I also had so like this is super weird. Like if look at the current working directory of my Vim, it's in source. But when I started Vim, I was like in the root of the crate. So somewhere I have some macro or some function or something that changes my current working directory, and I have no idea which one it is. So sometimes I just have to cd back out, because I believe I have an end-to-end test that actually has real assertions and a big schema and a whole bunch of stuff. And we commented that out because it was giving us some confusing error messages earlier on. So we'll just include that as well now. And it seems like that passed as well. Great, so the last thing that we basically need is to improve this error message here. I think I'll just uncomment this for now. So I just panicked that same field of same field name of different types. So let's think, what sort of error message do we actually want? In this case, we want something like both user and company have a field named country. But both the user and company have a field named country, but those fields aren't the same type. User country is of type country. Company country is of type other country. I think this would be a pretty cool error message if we could actually do this. Just gonna take this off. Yeah. So let's think, where's the actual data that we need? So I like to just sometimes like print all the sort of variables that we have. So we have the field name, both of the types, then we need this guy and this guy, user and company. Union type. By the way, this debug macro landed in stable Rust in the most recent version, I believe. 132, I think, and it is awesome. I've used it on nightly for a while, and it's so cool that it's finally unstable now. It basically it sort of prints like the file and the line number of where this macro gets called, the name of the variable, and then some like printed version of the value of that variable, and it's just super nice. It's much nicer than just doing a bunch of print lines and then you just have 20 of those and you have no idea where they're coming from and what variables they are. This is much nicer. Type, company, field name. So the type is company. We don't have the user. The type is the user at some point, right? Yeah. So when we insert a field, we basically say that we've seen a field of this name of this type, but we don't say what the name, like where that field came from. I think it would help us if we did that, because we basically need that in order to generate the error message, right? How would we do that? Because we cannot change the keys, because we need to still be able to look up by field name. So I think we need to change the value to also be whatever value this type is. That is a string. I wish these like all these types weren't just type aliases over strings. I wish there were actual like wrappers so that they had distinct types. Union type, we iterate over the types, so each of these is a named type. And we get a tuple. Let's just disregard the first value. So that works again. Let's say type with other field. Type with other field. And that went by so fast we didn't even see it. Now we have both. We have the user, the country, like the two types that have the field in common. We have the name of the field and we have each type that they have. So we should be able to build the error message now. So let's say let moot panic message. And then we can say panic message push stir. Whoops. Come on. And we can just panic with that message. And we fucked something up. And run the test. Let's do ourselves a favor and just push a couple of line breaks so that we can a bit easier see it, at least while developing. Let's push a few more. There we go. So this is just sort of our like hard-coded error message for now. We'll do the same for each of these. Format. Quick vim macro. Useless user format. Yep, that's just Clippy complaining, but it won't be useless later. And we're missing our line breaks, of course. So let's bring back our debugs. So user is field is type with other field. So we can bring that in here as well. Then we need whatever company is type underscore. The reason that we're using type underscore is because type is a keyword in Rust, so you can't have a variable named type. You can do like R hash symbol, is that what you call it? Like this, but this is just kind of hard to read and it becomes like blue in my editor, and we'll just leave it like this. Type. So the name of the field is this one then. Field name, field name, field name. And we need to borrow here. And which things are still hard-coded? Country and other countries seem to be the only ones. And country is other type. And finally, other country. Other country is field type name. Let's remove all the debugging. Check that nothing is hard-coded anymore. It looks good. Let's read the error message very carefully and check that it actually makes sense. So let's just copy it so that we can look at it outside of the output here. It says both user and company have a field named country. Let's just check user, company. They both, but those fields aren't of the same type. Aren't of the same type. User.country is a country. That is correct. Company country is a other country. That is also correct. Alright, I believe that takes care of that. Now the question is, can you actually test that this error message is correct? Because there's not that much logic here, but we still have to get the variable names right. And if we were to refactor it one day, we might accidentally fuck that up. Like, I would imagine that we're going to move all this junk into its own function, basically. And when we do that, we don't want to break anything accidentally. So I know that Rust has like panic hooks and stuff like that, so you can be notified when a panic happens. But can you get the message? Set panic hook, is that what it's called? Panic set hook. Function takes a panic info and returns nothing. What is the panic info? Can we get the message? We can. This is nightly only, of course. Payload. Return to the payload associated with the panic. This will commonly but not always be a string. Let's try that. basically what I'm thinking is we want to like call this hook and then actually verify that a panic happened. What happens if the panic hooks panic themselves? Set hook. Replacing any that was previously registered. Panic hooks invoked when a third panic before the panic runtime is invoked. Panics if called from a panicking thread. I wonder if it's just going to like infinitely recurse. I guess we'll find out. Nope. Thread panic while processing panic aborting. That's good. Now we just need to see what error message we actually get. Did it print anything? Illegal instruction. Think it printed anything. What if we just add an assertion? This should pass. Where did that fail? Why is it not? Why is it failing? Process didn't exit successfully. Okay. I guess we'll just leave that for now. Maybe we'll come back to it some other day. I guess we'll add a note that this error message is not tested. So all the tests should pass now. Yep. So let's try to do that thing that I talked about before, where if we pull all this junk into its own function. I suppose we can start by pulling this into its own function. Let's call it build. Just because like this is sort of a smaller piece that we can easily pull out. Build union fields set. Returns a hash set of hash field by name. Takes the union, which is a borrowed union type, and it takes the field map, which is, we have that right below, it's one of these. That should do it. And it does. Like, one of my favorite things about Rust is how it's like how the compiler is so strong that once your code works, refactoring it or sort of moving it around is very easy. And stuff like renaming types, variables, all these things are just handled for you by the compiler, which means that your brain is sort of free to focus on a whole bunch of other stuff, like more high-level things. So what do we call this guy? Let's say ensure field types don't overlap. I guess we could also panic if field types don't overlap. And then it's going to complain that a bunch of variables are undefined. So we're just going to, for each of those, we're just going to pull them in. And fields map, basically the same types as before. There we go. It compiles, it should still work. And it seems to do. And so in this particular case, I'm not worried about having fucked this up, because we copied the code as is and basically didn't change it at all. So this should all work. I will, however, move these to the bottom because they're sort of incidental to a lot of the other things that go on. Like if you read the file sort of from top to bottom, all this stuff is sort of noise. What I would like for you to focus on is like the high level picture, what actually happens, like what does the generated code actually look like, and not so much all these like nasty details. We're getting one hint from Clippy here though. We can convert this into an if let. Let's just do that while our cursor's here anyway. If let type def and There we go. I think we're actually done now. Let's commit. So I have two work in progress commits. I'll squash those. I just want to push it up, and then we can make a pull request and actually look at what the final code looks like and see if we made any silly mistakes. Just like doing a quick code review of our own code. So this, right off the bat, this is wrong. We want to keep this. We just commented it out so that it wasn't annoying during development. Let's bring this back. Still compiles. Push it up. So I'm basically just scanning it quickly to see if anything seems obviously wrong. I wish there's a way to get rid of these clones here. But I don't think I want to spend too much time on that now, since this is a procedural macro. Memory usage is not super important, and I'm not worried about these clones slowing you down, because realistically, how many types are you going to have in your schema? You're not going to have millions of different types. You're going to have 100 if you have a lot, and then 100 clones is very cheap. That's it. It's not too bad, actually. I don't think there's any documentation that we really need to update here, because again, it just works the same way that Juniper works. So let's squash our commits. I have a whole bunch of Git aliases. Git RBI is just an alias for interactive rebase. So it's like Git rebase I master, which lets you do a rebase but sort of choose what happens to each commit. So we can change these pics to S's, and an S basically means that it's a squash, which will take this commit and merge it into the one above it, which is this one, which will then be merged into the one above it. And then you can edit the commit message. So let's see what our previous commit messages were. Add caveat about using query trail with union types. We probably need to fix that. We can just reuse this commit message, I suppose. Generate query trail methods for unions. Let's have a look and see what this commit actually introduced. I think I remember there's some note in the README. Yeah. No, the union types current don't work. God damn it, that's a typo. Currently don't work with query trails, meaning that will not generate a message for each field in the union. Expect that to be fixed in a future version. If you can just remove that and just amend our commit. Force push it up. Generate query trail methods for unions. That's good. And then we can say that it fixes this. And so what I would like to do is I would like to actually set up Travis CI as the last thing today. I will do some more testing of this off stream, and then if everything seems to work, I think next stream we can then merge it, and then we can actually push it, and then we can figure out what we're going to do next. But I think as the last thing for today, I think we should set up Travis CI. I noticed last stream that for whatever reason we just hadn't done that yet. So when doing that, I like to do that on a separate branch. So I have done it for this crate, I believe. So basically what I want is just to copy over the config file. Build on stable beta nightly, add Rust format, I believe that is all. Cargo test all. Yep. Travis config. I love that setting up Travis for Rust is like this easy. It's just 15 lines. And let's go to Travis CI. I can never remember how to actually turn it on. I think it's here. Juniper from schema. Is that it? Do we need to push something? Basically, we just made a quick empty commit. We just push that up. I just need to see if it's actually configured correctly. It seems that it is. Let's hop in and see if it actually works. I don't think we need to set anything up in the config of the actual project, any hooks or anything like that. There's one for Travis. Did we add that manually? No. The first build is always exciting. Pearl brew. What the hell is that? Setting up build cache. Installing the compiler. 132, yeah. So 132 is the version that included the debug macro. I think what we're going to work on for the next stream is so we're doing this now. Yeah, I'd like to fix this one. So currently the, like if we look at the generated code, you can see that all the return methods of these like generated traits all return a field result, which is this Juniper type. A field result is basically a result or a field error. And it turns out that in some cases you might need to actually customize this error. So my sort of test project, like real world project, where I actually use this crate is a project, an experimental project that I'm doing at work, where we would like to, when there's some query that fails for whatever reason, we would like to track that particular error in our error tracking system. That's just rollbar. And we can't, like, we have no way of sort of hooking into Juniper and being notified that there was a failure. We just sort of get the final response that is a value, so like a JSON value in Rust. And so we could like look at that itself and check if there are any errors, and if so, do stuff. But it would be much easier to just sort of get notified by Juniper. So sort of a way to do that is actually these field errors. Let me see, how did that work? Yeah, so field errors can also be anything that implements into field error. We basically say how any type that could be your own custom error type, which is what this is about, how that converts into a field error. And a field error can basically be made from something that implements debug. So from any error type that will implement debug, that's super easy to make to implement this trait. So what we do is we then implement our own custom error type. That's just a regular enum, and then we implement into field error of that type. And then as part of doing this conversion, it also tracks the call in rollbar. I don't know if that's how you're supposed to do it, but that's sort of the best way of actually doing this that I've been able to find. However, that means that we need to be able to customize which sort of result type is actually used here, because like currently it's something like this, right? Field error. So we need to change this to some other type. Which could be like an app error or something like that. And so what that means is we need to somehow be able to tell the macro that it needs to use a different type. And I figured the syntax we just want is you can just say like comma error type colon and then whatever the name of your actual type is. And then it'll use that instead of the field error type. So I don't know how hard this is going to be. I don't think it's going to be that bad, because it will basically be like all these places where we return field result, we just need to change that to something else, and then somehow like the top level call to the macro will get whatever error type to use, and then if we don't specify it, it'll be field error. If we do, it'll be whatever we specified. So I don't think it should be that bad. The only thing I'm worried about is how do you actually parse this stuff, because if we look in the lib function, these macros themselves are basically just functions from some stream of tokens to some tokens, so it's basically from code to code. And we just have to somehow like parse it. I don't think it's going to be too bad, because it seems like you can just turn the input into a string, and then in this case we're just removing all these double quotes. So I guess this becomes a literal string with quotes around it. I don't remember, I wrote this code quite a while ago, but I don't think it's going to be too bad. But this is sort of the last, I think this is like the last sort of big feature left for this crate. Otherwise it's mostly feature complete. Oh yeah, one thing that I would also like to have that I forgot, that's like another big feature is supporting input values, default input values rather. But that's like a big can of worms, because you need to take how you wrote it in your schema, which GraphQL, the spec has sort of certain values that it allows as input values, and then you need to at compile time parse that and generate Rust values for that. So we're not generating types anymore, we're actually making values. And I've tried to work on it once previously, and getting it sort of fit into all the code is not quite trivial. But that would also be great to do a stream about, but that's a bit more involved. But let's see how far our tests got. They seem to have all passed. That is very nice. So we're just waiting on nightly here. It seems it has not even started. So I think I'm actually gonna end the stream somewhere here. We've successfully set up Travis now. All we basically have to do is wait for it to finish, just to make sure that it actually works, and then I'll just merge that into master, and then be good from there. If you're interested, feel free to look at the pull request that we made today, read the code, and if you have any questions, you can just comment them in here. Otherwise, if there's any other questions, now is the time. And as always, remember to follow me on Twitter. I always announce, or at least try to announce a bit in advance when these streams are. You're also very welcome to follow me on YouTube, where all the past streams are posted. And as soon as this is over, I'm also going to post this stream there. I don't know when the next stream is going to be. Hopefully sometime this week, but I'm not entirely sure. So yeah, I'll hang out for a bit longer, but in case there's any questions, just put them in the chat and I'll get to them. So I'll see you for the next stream. Bye.